Taylor is studying for her history exam. She studies at least 1 hour a day for 8 weeks, but she studies no more than 11 hours in any 7-day period. Prove that there is some period of consecutive days in which she studies for exactly 23 hours. I'm going to tell you that this is a pigeonhole problem. It's not too obvious to see exactly why, but the concept of having a period of days where you have to fit in a certain number of hours, like the concept of fitting in something, should remind you of the pigeonhole principle. So to start this off, I'm going to show you what this problem really means. You have 56 consecutive days, 8 weeks because it's 56 days. During 56 days, you study a minimum of 1 hour each day. But in any period of 7 days, you study no more than 11 hours. So you study no more than 11 hours. So the question is asking, prove that there is a certain number of days where you study exactly 23 hours. So say that this is n days, then you study exactly 23 hours. So this is what the problem is asking us right now. I'm going to introduce the notation of SI. Let SI be the number of hours Taylor studies until the ith day. I used S because it's the sum. For example, just give you an example. Say that she studied 1 hour in the first day, 3 hours in the second day, 2 hours in the third day, 1 hour in the fourth day. Then the corresponding SI would be, S1 would be 1 hour, because she's only studied 1 hour in the first day. S2 would be 1 plus 3, which is 4. S3 would be 1 plus 3 plus 2, which is 6, and so on. So that's what SI is. And then what we're trying to find is for some ith and jth day, where let's just say j is bigger than I, where this is satisfied, there exists Sj minus Si, where it is exactly 23. And this is because during the interval of 56 days, where this is 0 and this is 56, and I is right here, and j is right here, the number of hours she studied during this period is Sj. And also the number of hours she studied during this period is Si. We need to show that right here, Sj minus Si, this is exactly 23. So this is what we're trying to prove. We also know that there are 8 weeks, and she can only study 11 hours per 7 days. So in total, during the 56 days, she can study a maximum of 88 hours in total. So this inequality is just, say, number 1. We know that minimum of 1 hour on the first day. S1, S2, all the way up to S56 is less than or equal to 88 hours. We're going to create another one where we add 23 hours to each term. So this becomes a minimum of 24 hours. S1 plus 23, S2 plus 23, all the way up to S56 plus 23 is less than or equal to 88 plus 23, which is 111. Now this is where we're going to use the Pigeonhole Principle. So looking at this right here, we have a total number of 56 plus 56 terms, which is 112 terms. So this list right here, S1, S2, all the way up to S56, and also S1 plus 23, all the way up to S56 plus 23. We have 112 of those. But looking at this 124, 88, 111, we know that this number right here is also between 1 and 111. The Pigeonhole Principle tells us that, well, there are 112 numbers and a range of 111 numbers, and these numbers are all integers. So there must be two numbers between this set right here that are equal. So let's look at this again. We concluded that two numbers in this set are equal, but S1 is smaller than S2 and is smaller all the way up to S56, so there's no way two numbers here could be equal. Similarly with this, S1 plus 23 is smaller than S2 plus 23 and is smaller than S56 plus 23, so there's also no way two numbers in here could be equal. So this shows us that one number from the first inequality, say Sj, and then one number from here, let's say Si plus 23, have to be equal. So what we can conclude is that Sj equals Si plus 23. Subtracting Si from both sides, we get Sj minus Si equals 23. And let's compare this to the initial thing we had to prove, which was right here. Sj minus Si equals 23. And using the Pigeonhole Principle, we proved that that is indeed true. So there exists a period of j minus I days where Taylor studies for exactly 23 hours.